Welcome to the Merlin and Metro News Network. Today's program is an overview of the environmental system. In fact, the next 4 tapes will cover environmental and related systems. Each of these systems has proven to be very reliable, but when one of them does malfunction, it sometimes leads to troubleshooting problems. This is because the smaller systems that make up the complete environmental system all interact. Often the biggest impediment to troubleshooting is deciding which system is malfunctioning. As we progress through this and succeeding programs, you'll see how each of these systems works together to provide environmental control. And now let's roll our first program.
The environmental system provides increased passenger and pilot comfort during flight. Heating, cooling, and pressurization of the aircraft cabin are provided for by the environmental system. While these functions are performed by different systems, they all interact closely to provide environmental control. Each system features both an automatic control and manual pilot override capability. An internal series of ducts and controls is used to distribute the environmental supplied air throughout the cabin and cockpit. The source of power for the environmental system is bleed air, extracted from each engine. This source is also used to power the utility systems, the de-ice and vacuum systems. This pressure is routed from a pad on the side of the engine through the firewall and to a component called the flow control valve, installed on the left-hand side of each main gear wheel well. The flow control valve regulates the amount of air extracted from the engine and serves as a shutoff valve to stop air being extracted from the engine. 2 additional components assist the flow control valve in performing these tasks. A flow-limiting venturi is used to limit the maximum flow through the line, while a regulator valve is used to determine the precise amount that can be extracted. It should be noted that the bleed air necessary to operate the de-icing and other critical systems on board the aircraft tees off and is separate from the flow control valve regulation. After exiting the flow control valve, environmental control bleed air is routed via ductwork through the wing center section, where it splits into 2 separate paths. Part of the air is routed to the air conditioning cooling turbine. The other path takes the air to a hot air mixing valve, where it is used by the heating system. The air cycle machine, or cooling turbine as it's sometimes referred to, receives very hot, high-pressure bleed air, and through an expansion process creates lower-pressure cold air. A separate anti-icing subsystem is provided to prevent condensation in the cold air from freezing. This freezing could result in blockage, which would diminish the airflow and possibly throw the turbine blades out of balance, which could damage the turbine. Mixing of the cold air provided by the cooling turbine and hot air provided by the mixing valve is controlled by a separate electrical system. The system has a cabin air temperature sensor located in the cabin and cockpit controls to allow the pilot to adjust the cabin air temperature. The airflow provided through both the heating and cooling system is being introduced into a sealed cabin. Obviously, the pressure inside of the cabin will continue to increase as more and more air is introduced, unless it's controlled to keep it at a safe and comfortable level. A pressurization system is installed to regulate the outflow of air from the cabin. This is the basic concept sometimes overlooked by mechanics. The environmental system essentially introduces the same amount of air to the cabin at all times. The pressurization system regulates what air is allowed to escape from the cabin, not what is allowed to enter. The pressurization system will regulate the pressure within the cabin to provide the most comfort for the passengers while not exceeding the safety limits of the structure of the aircraft. A controller in the cockpit provides automatic control of the cabin pressurization levels, with a manual override system provided as well. The manual control system is very coarse and would only be used in an emergency. Indications for the pressurization system include a cabin rate of climb indicator and cabin pressure indicator. An indicator within the pressurization controller itself is also used to provide an indication of system status. The pressurization system uses two valves to control airflow out of the cabin. The outflow valve located on the aft pressure bulkhead is the primary control means. It is controlled by either the automatic controller or the manual system. These systems control the opening and closing of the valve by varying the amount of vacuum applied to the valve. The emergency dump valve is located on the left-hand upper corner of the forward pressure bulkhead. It is controlled by a switch in the cockpit. Unlike the outflow valve, which is constantly modulating or adjusting the rate of cabin air exiting the aircraft, the dump valve is closed during most flight regimes. Both valves also feature automatic provisions, which will cause them to open under certain pressure conditions. A fresh air system is installed for the cockpit, which can provide air drawn from the nose baggage compartment for the pilot and co-pilot. Indication systems include a cabin altitude warning system to inform the pilot that the equivalent altitude within the cabin is high enough that oxygen is needed. An amber light on the annunciator panel will illuminate when the cabin exceeds 11,500 feet altitude. This may or may not be the same altitude at which the aircraft is operating. If the pressurization system is operating normally, this light will never be seen. The cabin rate of climb and cabin differential pressure indicator are used to monitor the operation of the pressurization system. The rate of climb indicator shows the rate of change of cabin pressure the aircraft's occupants are experiencing, not the actual rate of climb of the aircraft. The differential pressure indicator will show the altitude of the aircraft and the relative altitude of the cabin. It will also indicate how much of an absolute pressure differential exists between the aircraft cabin and the ambient pressure. The cabin temp indicator is used to indicate the cabin temperature, so that the pilot may adjust the heating and temperature control for passenger comfort. There are also lights that indicate a failure of the cooling turbine or other high-pressure bleed air leaks. While these items monitor environmental system components, they are properly part of the fire protection system and will not be discussed during these programs.
That concludes our overview of the environmental system. Our next program will move directly into the system that provide heating and cooling for the aircraft cabin. Until then, good flying and good maintenance.